Linear motor instructional video. Constant technology advancements have made people's lives convenient and comfortable. Everywhere in our daily lives, we can notice the effects of technologies that are derived from little inventions that lead to major advances. Transmission is one of them. What is linear motion? In a nutshell, it consists of moving an object from one place to another via linear movement. There are countless transmission products employing linear motion. Even if you don't fully understand the principle of transmission, you are certainly using it in your daily life. Furthermore, this principle is used in many kinds of machinery, which are used to produce other technology products that we also use in our everyday lives. What are linear motors for? Actually, in the beginning, people started thinking of other automation elements to do this type of work in order to increase efficiency. People therefore used racks and pinions, belts, and even hydraulic or pneumatic devices to convert motion into force via Pascal's principle and move heavy objects. These kinds of linear transmission elements include pneumatic and hydraulic cylinders, like those used in power shovels. Other kinds of linear transmission elements include ball screws and motors. However, when faster speeds are needed, some transmission elements are no longer able to meet the current requirements. Later on, linear motors evolved from motors. You can visualize a so-called linear motor as a rotary motor that has been cut open along its axis and then spread out, so that the motor's rotary motion becomes linear motion. This is a linear motor. The internal elements of a linear motor include a forcer, stator, a guideway, a forcer plate, and a position encoder. Forcer. This is also the primary side and includes a coil, iron core, and thermal protection device. Stator. This is also the secondary side and includes magnets, a base, and a shield. The guideway functions similarly to the bearings in a rotary motor, enabling the linear motor to perform linear movement. Forcer place, the base on which the mover is mounted. The position encoder provides feedback concerning the position of the linear motor and enables precise control. Why does the forcer move? The forcer moves when the driver supplies different currents to the forcer at different times. You can see from the animation that when the coils are supplied with current in different directions, and there are large and small currents, the relative positions of the forcer and the stator will be different. The constantly changing current undergoes what is known as commutation, which is what causes the forcer and stator to undergo relative motion. Continuous current. A continuous current is defined as a current that can be continuously supplied to the motor coils. This current typically does not cause the temperature to exceed 100 degrees Celsius as it flows through the coils. Continuous force. Continuous force is defined as the force produced by the motor when a continuous current with a 100% load ratio is applied to the motor coils. Encoder resolution. Encoder resolution is defined as the smallest distance that can be measured by the position feedback system. Finite element analysis of mechanisms and 3D computer design. To ensure a machine has a high level of accuracy, software tools can be used in the design of a linear motor platform to analyze the strength and deformation of components. This can enable places where deformation may occur to be reinforced, improving the platform's flatness, linearity, and overall accuracy, and achieving the goal of optimized design. A computer-assisted finite element analysis is usually employed to achieve this goal. Computer-assisted 3D design can also be used to discover interference issues early on. Magnetic circuit analysis. The geometric shape of the forcer will influence the magnetic field distribution, which will in turn affect the thrust density. The cogging force of an iron core motor will depend on the design of the forcer. Because effective magnetic circuit analysis of the mover and stator can provide suggestions for design improvement, 2D or 3D magnetic circuit analysis software can be used in conjunction with a CAD system, enabling visualization of geometric shapes to perform simulations and decrease the chances of mold failure. Motor thermal analysis. A motor's cooling efficiency can indirectly affect its power output. Computer-assisted thermal analysis software can be employed to find ways of quickly and effectively dispersing the heat generated when large currents flow through a motor. Guideway installation. The guideway serves to direct linear motion. As the forcer travels, the guideway maintains the gap between the forcer and stator. Guideway adjustment adjusts the linearity and parallelism of the guideway, improving the platform's positioning characteristics. Position encoder installation. The position encoder is the chief method of ensuring positioning accuracy and is the basis for motor servo control. Forcer plate installation. The forcer plate serves to connect the forcer and blocks and helps the forcer disperse heat. Forcer installation. Joining the forcer and forcer plate. To prevent mutual attraction, special care must be taken to avoid letting the forcer get too close to the stator during installation. Stator installation. Because the stator possesses great magnetic strength, care must be taken to maintain safety during installation. Laser measurement. After assembly, a laser interferometer is used to measure the accuracy and repeatability of the completed linear motor positioning platform. Linear motors are currently used in a wide range of applications, including water jet cutting machines, CNC drilling machines, CNC laser processing machines, aspherical processing machines, AOI optical testing machines, PCB X-ray testing machines, semiconductor manufacturing and testing equipment, SD cartridge water jet cutting machines, wafer mask machines, FPD manufacturing and testing equipment, FPD laser cutting machines, FPD testing machines, high vacuum environmental testing equipment, and solar power testing equipment. LMS Iron Core Linear Motor Series. LMS Iron Core synchronous linear motors are the linear transmission products offering the highest force. The three-phase motors in these products have a stator, iron core primary sides and secondary sides comprising the forcer and permanent magnets. Because the stator can be extended without limit, there are no restrictions on the stroke. LMC Ironless Linear Motor Series. LMC synchronous linear motors are natural-born sprinters. They are lightweight and have outstanding dynamic characteristics. This is because there is no iron core, and the coils are sealed using a special sealing method. The motor only has to bear a small amount of its own weight while operating. The secondary side contains a U-shaped stator made with a permanent magnet. XY stage. Different X and Y travel can be achieved by combining different kinds of linear motor stages. Characteristics include high force, high speed, repeatability of 1 micrometer, resolution of 1 micrometer, and perpendicularity under 5 arc seconds. Can be applied in probers, PCBs, wafers, LCDs, wire bonding machines, die bonding machines, laser engraving machines, insertion machines, and coordinate measurement instruments. Little inventions that lead to major advances. Linear motors.